Today we're solving for quadratic roots and the discriminant. It's actually a pretty short lesson, so we might even be able to finish it in the 34 minutes we have left. To be able to do that, you need to be able to graph quadratic functions, and luckily we've been doing that in every lesson so far. You need to be able to define quadratic roots and identify them on a graph, and to use the discriminant formula to determine the number of roots a quadratic function has. I am recording now. I'll link it in the slides later. The practice will just be evens or odds. I know my first hour had time to work out on it. My second hour didn't. Either way, I'll still give you, I don't know, 20 minutes tomorrow or so. We'll just have to see when we finish. But no more than like 25 minutes that I'm going to give you. And then we're going to do the exit ticket for this lesson and then keep moving along. So you can expect the exit ticket for this to be tomorrow, and you'll use your notes on it like you always do. And it will be in the lockdown browser again, so just be patient with it. We'll just see if it works. All right, so now on to the notes. First, we have quadratic roots. And those are going to be the points at which the parabola intersects the x-axis. All right, the points at which the parabola intersects the y-axis are your quadratic roots. There's other names for it, which you will have to recognize on a test. It might say identify the roots. It might say identify the zeros of the quadratic function. It might say, what are the solutions? And then there's one more, which I hope you guys can tell me. What's it called when something intersects the x-axis? What are those? Not y-intercepts, because it's the x-axis, but x-intercepts. So when it's asking you about your zeros, your solutions, your quadratic roots, it's really just asking what are the x-intercepts. All right, there's a few options for how many solutions you can have, or zeros, roots, whatever you want to call them. And the most that you can have are 2 solutions. So it might look like this, where it touches the x-axis 2 times. And there's tons of other solutions you can have, or examples you can have of 2 solutions. Here's just one of them. It'll never touch more than twice on the x-axis. And the way that I would write what my roots are, or what my solutions are, is I would put x equals, and then these curly braces. So it's kind of like a parenthesis, but fancy. It's above the bracket symbol on your keyboard. And you're just saying what x value it intersects at. So this one doesn't have lines, but if I had to guess, it kind of looks like it goes through -2. And let's say 4. All right, so whatever x values it intersects at, then that is your roots. That's your zeros. That's your solutions, your x-intercepts. So questions about that? If I only have one solution, how many times is it touching the x-axis? once. Good. So then it might look like this for one of the examples. All right, you could also draw it the other way. You could have a positive parabola. But if it only touches the x-axis once, then you only have one solution. And in that case, you only have one number in your curly brace. So what would you estimate it to be at right here? All right, good. And there's no lines. So, I mean, you might say 3, you might say 5, I don't know, but just wherever it intersects at. Good. And then if there's no solution, how many times does it touch the x-axis? No times. 0. All right, so it might look something like that, or maybe the other way, but still not touching the x-axis. Mostly they just write no solution when it's no solution, but I've also seen them go like this when it's no solution. But most of the time they write it out. So any questions? All right. Now these examples, really what we're trying to get you to do is identify the solutions or the roots, the x-intercepts, whatever you want to call them. When I'm taking a test in Galileo, I'm not going to really waste my time in graphing it by hand on my paper. I will just use my graphing calculator and see where it crosses the x-axis, which is something that you guys could do on your Galileo test as well. When you're doing your retake though, the questions are gonna look just like this from your notes. Literally probably gonna be copy and pasted. So you will have to do it by hand and show all your work, like give you some blanks to fill in for axis of symmetry, for vertex, for domain and range, and then we'll just add in another blank to say the solutions or the zeros, whatever you want to call them. So do on your practice all the work shown that we're going to do on the notes, even though, yeah, you can just use Desmos and that's probably faster. We'll do it by hand to prepare for the retake. So then when it's in standard form, because vertex form is what we did yesterday, vertex form is on the board. The equations right now don't look like that, do they? They look like standard form, which is what we're used to. So when it's in standard form, you have to find the axis of symmetry with this formula. Remember, negative b over 2a. What number is in the b position? 4. Use parentheses when you plug stuff in. So far I have a negative 4 because it's supposed to be negative b. Over 2 times a, what number is in the a position? 1 is correct. And you can use Desmos to simplify that. You can do it by hand. This one's not that bad. What's negative 4 divided by 2? Negative 2. So put that into the x of your vertex, right? Because the axis of symmetry, x equals negative 2, tells you the x of your vertex. How do you find the y of your vertex? Use your words. How do we find the y? Plug in the x. All right, since it's not in vertex form, I can't just look at the equation and know what it is. All right, I do have to plug it in this time. This is what I would want to see for your scratcher, is you plugging it in with the parentheses for at least one of the x's. I don't expect you to do it for all of them. But you use your calculator for the rest of it. So that's what I'm going to do. You should do the same on yours. All right, but the Desmos graphing calculator, make sure that you use your parentheses because it will make a difference if you don't. And if you're getting anything other than -9, if you're getting anything other than that, then let me know because I can tell you what you're doing wrong. But you should get -9. All right, and we discovered earlier that in the lockdown browser, it doesn't let you copy and paste like I've been showing you that you can do. But you can just go back and change the X each time. Yeah. Sorry.
I'll sure check it.
Sorry, hopefully they fix it. I don't know what else to do about it. All right, but what X's do we need to plug in next? Like, how do I know what X's to pick for my table? So some numbers before -2 are, well, -1 is after -2. Good. So it's all based on the X of your vertex. And then to the right on the number line?
0 and 1.
Good. All right, so you pick your X's based on the X of your vertex. You'll want some to the left and to the right. So left and right is your X's. And yes, these are what we're plugging into Desmos now. So just keep in mind, it's not like a vertex form where a vertex form only has one X. You have 2 X's that you need to change. If you use the parentheses, then you should be able to clearly see what you need to change. All right, so all I'm doing is changing the X's. Hopefully you're doing the same thing and practicing. Otherwise, that's what you use to fill in your table. So when X is -5, Y is, when X is -4, Y is, when X is -3, Y is. Good. And then you should start seeing them kind of reflect each other. Like when X is -1, Y is -8. When X is 0, Y is, and then when X is 1, Y is 0. All right. Now, once you've done that, transfer it onto your coordinate plane. So try it yourself first, and we'll just see if you do it right. So try not to look at the screen until you're done. All right, so then once you're done, look at the screen for how the dots should be, then connect them to your U-shaped parabola. And mine always looks ugly, but yours should be nice U-shaped. Now, last thing we need to do is identify the solutions, the roots, the x-intercepts. So look at your x-axis. Is it the vertical axis or the horizontal one? The horizontal one. Look visually where it crosses the x-axis on your paper. What x values are those? -5 and +1. So this one has 2 solutions. So I have 2 in my little set of curly braces. You can see that from your graph. You can also see it from your table. Because if you remember, like y-intercepts are when x is 0, while x-intercepts are when y is 0. So anytime y is 0, those are your x-intercepts. Questions about that? All right, so do the same with number 3 from scratch. I know you can do it on Desmos also, but try number 3 showing all this work. I'll give you about 2 minutes and then I'll see. I think that should be enough time, but we'll see. All right, so practice with the graphing from scratch and then I'll show you how to easily find your solutions with Desmos. All right, but when the equation's in standard form like it is now, how do you find your vertex that would normally go in the middle here? What's the first thing you usually have to do? Good. You need to do the axis of symmetry formula, which will tell you the x of your vertex. So then what number is in the B position? Yeah, it's okay. I'll show you 2 in a second. All right, but yes, the number in the B position is 2. The number in the A position is what? In the trash. -1. And then simplify it. Use Desmos if you want. This one's not that bad. What's -2 divided by -2? -2 divided by -2 is +1. Good. So that's the x of your vertex. Also, axis of symmetry is x equals 1. Miss Medina. Yes. Okay. No problem. Bye. Okay. Dean, the sweep lady, said to disregard the detention she just assigned you. Okay, I guess it was a mistake. I don't know. Sorry. Anywho, that's the x of your vertex is what I just said. How do you find the y of your vertex? You plug in the x into the given formula, which is what I did. This is what I would like to see on your papers at a minimum for your scratch work. All right, I don't expect you to do that by hand. Use Desmos and make your life easier. And what do you get for the y of your vertex? No one feels confident in their answer? Okay. So then -2 is what you should have had. So if you got that and you're just too scared to say, just know you're on the right track. So then -2 is the y of your vertex. Now fill in the rest of your table. What x's should I pick? Two, 3, and 4 would be good ones. What else? Good. All right, numbers before the x of our vertex and after. And then the y's you find in the same way we found the y for the vertex. Plug in these x's. All right, to save you some time, because you guys should have already done it. Right? This is what you should have. -11, -6, -3, we already have the vertex, -3, -6, and -11. Transfer that onto your coordinate plane. Can I put -2, -11 on this? No, because it doesn't fit. It would be like down here. So just skip that one. you can plot -1, -6, which would be there. 0, -3, 1, -2, 2, -3, 3, -6, and then the other one you can't do. 4, -11 would be done. Now your solutions are where the parabola touches what? The x-axis. Does this parabola touch our x-axis? So then how many solutions do we have? No solutions. All right, so number 3 would be no solution because it doesn't even touch the x-axis. All right, now I'll show you how we do it with Desmos super quick. Like that's what I would do to verify my answer. And that's what I would do if I didn't have to show work on my test, like the Form A. All right, but I would just type in the given equation. So the -x² plus 2x minus 3. And zoom in, we see our x-axis is right here. It doesn't touch it. I know that there's no solution for that one, which is what we said. If I type in the one for number 2, which I know I didn't ask you to do, but we'll fill in the answer. Hover over where it touches the x-axis. And what's that solution for number 2? Is it 2 solutions, 1 solution, no solution? And that solution is 1. All right. On the back side of your notes, use Desmos to find these solutions. I'll give you like a minute to do that because that's really how long it takes. Yeah, you're not doing them all by hand. I won't make you do that. But I'm going to make you list what the solutions are just on these 3 lines right here using Desmos. You have 2 solutions. Here's what it should look like when you put it into Desmos on the right. All right, it touches the x-axis twice. So what are my 2 solutions? 2 and 8. How many solutions does number 5 have? Well, let's see.
No.
It has 2 solutions again. It touches the x-axis twice, right? Then what are my 2 solutions? -3 and +3 are your solutions for number 5. Lastly, number 6, how many solutions was that one? 2 solutions again, and this time they are 0 and 2. All right, so whatever number is in the X spot is your solution. All right, does that make sense? Any questions? All right, still want to see you do on your practice how we did it, like in number 1 and 3. Real quick, we still have to do the discriminant. So the discriminant is used to determine the number of solutions algebraically. So maybe instead of graphing the whole thing, we can just use this formula to determine the number of solutions. All right, it won't tell you what the solutions are, unfortunately, but sometimes on your test, it just wants to know how many solutions will this have, 2, 1, or 0. The formula for it is b² - 4ac. Now, does that look familiar at all? Where have you seen it? All right, it's part of your quadratic formula, which we haven't covered yet. We'll cover it some other day. But, you know, part of your quadratic formula is your axis of symmetry. The other part is your discriminant. Except in the quadratic formula, it normally has a square root. Stop packing up. All right. When we plug in the A, B, and C into this formula, if the value is greater than 0, so basically if it's a positive number, you're going to have 2 solutions. Because normally in the quadratic formula, we would square it or take the square root of it. And there's usually like the positive and the negative of that. If it equals 0, what's the square root of 0? 0. And can I have a positive and negative 0? No. So if it equals 0 exactly, then you just have the one solution. And then if it's a negative number, can you take the square root of a negative number? No. If you try it out in Desmos right now, like square root of negative 36, it'll say undefined because you can't. So fill this in. We'll just do number 7 today. So identify your A, B, and C. What's A in number 7? What's B? And what's C? Now plug it into this formula. So it's B squared, which we said is 5 squared, minus 4, times A, which we said is 1, times C, which we said is 4. Now, for the sake of time, normally I'd have you try it out in the calculator, tell me what it is. But for the sake of time, I'll tell you it equals a positive 9. So in that case, how many solutions do I have? 2, 1, or 0? 2 solutions. Because it's a positive number, right? Is 9 greater than 0? And there's 2 solutions.
All right, I'm going to do a few more examples just because I didn't want to end the video with only one example of the discriminant. But, so here's a few more, and then my class will actually see the rest tomorrow. So always identify your A, B, and C for each example. So take the time and do that. It'll save you a lot of problems later. So A, the number in front of the x squared is 1, B is -3, and C is 10 in this one. So the signs in front of each term matter. So if it's negative, you need to put that it's negative. And then plug it into your discriminant formula. So B squared, so -3 squared, minus 4 times A, which we said is 1, times C, which we said is 10. Now I'm going to put that into Desmos. That's what I recommend you do unless you're really good at order of operations. And you need to use the parentheses. The parentheses matter. If you don't, the calculator will read it wrong, especially in these problems. All right, when I enter that for number 8, I get a -31. And then I just use my little key here to determine, well, since it equals a -31, how many solutions I'll have. So it's not greater than 0, it doesn't equal 0, it is less than 0. -31 is less than 0. So in that case, then I have 0 solutions for number 8. All right, now let's do number 9, and then we'll call it there. So actually, let's do a different one. Let's do number 11. All right, so number 11. we're gonna have A equal to 4, B equal to -12, and C equal to 9. All right, plugging it into our formula, we get -12 squared minus 4 times 4 times 9. So just see how all we did was plug in these numbers into this discriminant formula. All right, plug that into the calculator. So this time we have -12 squared. Make sure you put that in parentheses. 4 for the A and 9 for the C. And we get that that equals 0. So when my discriminant is 0, you can use the little key that we made here. And when the discriminant equals 0, then there's one solution. So that's all we are really asking in these problems, is just tell me, is it 1, 2, or 0 solutions? It won't tell you what the solutions are. You'll have to graph it, at least for now. I'll show you other ways in the future. But this will tell you the number of solutions, and sometimes that's all it wants on a test. It's just how many solutions are there.